Download this code from codegive.com, link in the description below. Building automated tests with generative AI, a deep dive. Generative AI, particularly large language models, LLMs, is revolutionizing software testing. It allows us to create automated tests more efficiently, effectively, and with broader coverage, especially in areas traditionally challenging for manual testing or traditional test automation. This tutorial will guide you through the process of leveraging generative AI to build automated tests, covering essential concepts, practical examples, and considerations. Understanding the potential and limitations of generative AI in testing. Before diving into the code, it's crucial to understand what generative AI can and cannot do for automated testing. Strengths * test case generation * automatically generate test cases from requirements documents, user stories, API specifications, or even existing code. * test data generation * create realistic and diverse test data, minimizing the effort needed to manually craft data sets. * test code generation * generate test code snippets, example assertions, setup, teardown, based on natural language descriptions of desired behavior. * test script maintenance * assist in updating test scripts when the application under test changes. Mutation testing * generate mutations of the code to identify weaknesses in existing test suites. Exploratory testing assistance * suggest potential test scenarios based on application knowledge. Bug detection * identify potential bugs based on code patterns or anomalies. Limitations requires high-quality input * the quality of the generated tests heavily depends on the quality and clarity of the input, requirements, specifications, code. Garbage in, garbage out. Potential for bias * LLMs are trained on vast data sets, which may contain biases. This can lead to the generation of biased tests. Lack of contextual understanding * LLMs may struggle with complex or nuanced application logic. They often lack the deep understanding of the system's purpose and business domain that a human tester possesses. Hallucinations * LLMs can sometimes generate incorrect or nonsensical code or test cases. Careful review and validation are always necessary. Integration overhead * integrating generative AI into existing testing frameworks can be complex. Ethical considerations * consider potential ethical implications of using AI-generated tests, especially regarding data privacy and security. Dependency on API availability and cost * using commercial LLMs comes with API costs, and service availability can be a factor. 2. Choosing the right tools and technologies. Several options exist for leveraging generative AI in testing. Commercial LLMs, example OpenAI's GPT models, Google's Gemini, Anthropic's Claude. These offer powerful text generation capabilities via APIs. They are generally easy to integrate and offer a wide range of functionalities. However, they require a paid subscription. Open source LLMs, example Llama 2, Falcon. These models can be deployed on your own infrastructure, giving you more control and privacy. However, setting up and managing these models requires significant technical expertise and resources. Specialized AI-powered testing tools. A growing number of tools are designed specifically for AI-assisted testing. These tools often provide a more user-friendly interface and may be tailored to specific testing needs, example UI testing, API testing. Examples include Testim, DiffBlueCover, Functionize, Applitools. Asterisk libraries and frameworks. Asterisk you can use Python libraries like LangChain, transformers, and OpenA to build custom testing tools and integrations. For this tutorial, we'll use OpenA's GPT 3.5, or GPT-4, as a starting point, as it's widely accessible and well documented. We'll use Python and the OpenA library for integration. However, the general principles can be applied to other LLMs and tools. 3. Setting up your environment. 1. Install Python *. Ensure you have Python 3.7 or later installed. 2. Install the OpenAI library *. Open a terminal and run. 3. Obtain an OpenAI API key *. Go to https://platform.opena.com/ https://platform.openai.com, and create an account or log in. Navigate to the API keys section. Create a new API key. Important *. Treat your API key like a password and keep it secure. Do not commit it to your code repository. 4. Set the OpenAI API key as an environment variable *. 4. Generating test cases and code with OpenAI. Let's illustrate how to generate test cases and code using OpenAI's API. We'll start with a simple example and then move to more complex scenarios. Example 1, generating test cases for a calculate_discount function. Suppose we have a function that calculates the discount for a customer based on their purchase amount and membership status. Here's how we can use OpenAI to generate test cases for this function. Python. Function_description. Explanation *. 1. Import libraries *. Imports the OpenAI library for interacting with the OpenAI API and the OS library to access environment variables. 2. Set API key *. Retrieves the OpenAI API key from the environment variable OpenAI_API_key and sets it for the OpenAI library. 3. Generate _test _cases function *. Takes the function description and the number of test cases to generate as input. Constructs the prompt *. This is the most important part. We craft a detailed prompt that instructs the LLM to act as a software testing expert. Generate test cases with specific formats, description, input, expected output. Cover various scenarios, including boundary conditions, valid/invalid inputs, and edge cases. Calls the OpenAI API. Uses the OpenAI.chat.completions.create method to send the prompt to the OpenAI API. Model specifies the GPT model to use, example GPT 3.5 Turbo, GPT-4. GPT-4 is more powerful but also more expensive. Messages, a list of messages in the conversation. We provide a single message with the role user and the content of our prompt. Temperature, controls the randomness of the output. A lower temperature, example 0.2, produces more deterministic results, while a higher temperature, example 0.8, produces more creative results. Max_tokens, limits the maximum number of tokens in the generated response. Adjust this value based on the complexity of the function and the desired length of the test cases. Parses the response. Extracts the generated test cases from the API response and splits them into a list. Error handling. Includes a try, except block to handle potential errors during the API call. 4. Main execution block. Defines the function_description variable with the Python code of the calculate_discount function. Calls the generate_test_cases function to generate 5 test cases. Asterisk prints the generated test cases in a user-friendly format. Example output will vary. Example 2, generating p-test code from test cases. Now, let's take the generated test cases and automatically create p-test code for them. Python function_description chr10.join test_cases explanation asterisk 1 generate_p-test_code function asterisk takes the function name, function description, and test cases as input. Asterisk constructs the prompt asterisk. This prompt is designed to generate p-test code based on the provided test cases. Asterisk instructs the LLM to act as a Python/p-test expert. Asterisk provides the function name and description. Asterisk includes the generated test cases from example 1, concatenated into a single string. Asterisk specifies the desired coding style, including using assert statements, handling exceptions, and including necessary imports. Asterisk calls the OpenAI API asterisk similar to example 1, it calls the OpenAI API to generate the p-test code. Asterisk parses the response asterisk extracts the generated p-test code from the API response. Asterisk error handling asterisk includes error handling. 2 main execution block asterisk defines the function name and description. Asterisk generates test cases using the generate_test_cases function from example 1. Asterisk calls the generate_p-test_code function to generate the p-test code. Asterisk prints the generated code. Asterisk optionally saves the code to a file named test_calculate_discount.py. Example generated p-test code will vary via advanced techniques and best practices. Asterisk prompt engineering asterisk experiment with different prompt styles and phrasing to improve the quality of the generated tests. Be specific, provide clear instructions, and use examples to guide the LLM. Iterate on your prompts to fine-tune the results. Consider using techniques like few-shot learning, providing examples of desired output. Asterisk chain of thought prompting asterisk for complex functions, use chain of thought prompting to guide the LLM to reason step by step through the logic and generate more accurate test cases. Ask it to explain its reasoning before giving the final test case. Asterisk data augmentation asterisk use generative AI to augment existing test data sets. Generate variations of existing data to cover a wider range of scenarios. Asterisk integration with existing testing frameworks asterisk integrate the AI-powered test generation process with your existing testing frameworks, example ptest, JUnit, Selenium. You can write custom scripts or use libraries to automate the process of creating and running tests. Asterisk human in the loop asterisk always review and validate the generated tests. AI is a tool to assist, not replace, human testers. Human testers can identify edge cases, biases, and other issues that the AI may miss. Use the AI to accelerate the testing process, but always retain human oversight. Asterisk refactoring and maintenance asterisk as the application evolves, use generative AI to assist in refactoring and maintaining existing test suites. The LLM can suggest updates to test cases based on code changes. Asterisk feedback loop asterisk implement a feedback loop to continuously improve the AI-powered test generation process. Track the performance of the generated tests and use the results to refine the prompts and training data. Asterisk test coverage analysis asterisk combine AI-generated tests with traditional test coverage analysis tools to ensure adequate code coverage. Asterisk security testing asterisk use AI to generate test cases specifically designed to identify security vulnerabilities. *UI testing *Use libraries such as Selenium or Playwright and combine it with the LLM's ability to describe UI interactions. This can help automate the writing of functional UI tests. *API testing *Use OpenAPI, Swagger, specifications as input for generating API tests. The LLM can automatically create requests, validate responses, and test different API endpoints. *Model fine-tuning Consider fine-tuning open-source LLMs with domain-specific data to improve their performance on testing tasks. This requires more resources and expertise, but can lead to significant gains in accuracy and relevance. *Use vector databases for context *Use vector databases like Pinecone or Chroma to store and retrieve relevant information about the application under test, example requirements, design documents, code snippets. This allows the LLM to access contextual information and generate more informed tests. *Cost management Monitor the API usage and costs associated with using commercial LLMs. Optimize prompts and reduce the number of API calls to minimize expenses. Consider using cheaper models for simpler tasks. 6. Example, generating a UI test using Selenium with Generative AI. This example uses Selenium and OpenAI to generate a simple UI test for a hypothetical login page. It requires Selenium and a web driver, example Chrome driver for Chrome, to be installed. You will also need to install Selenium. Explanation *. 1. Import libraries * imports necessary libraries, including OpenAI, Selenium, and ptest. Import options to run Chrome in headless mode, optional but recommended for automated testing. 2. Set API key * retrieves and sets the OpenAI API key. 3. Generate _Selenium _test function *. Takes the website URL and scenario description as input. Constructs the prompt *. This prompt guides the LLM to generate Selenium code. It specifies the desired coding style, including handling exceptions, using explicit weights, and including necessary imports. Calls the OpenAI API calls the OpenAI API to generate the Selenium code. Parses the response extracts the generated Selenium code from the API response. Error handling includes error handling. 4. Ptest fixture for WebDriver setup A ptest fixture is used to set up the WebDriver before the tests, and tear it down after. This allows the WebDriver to be shared and avoid repetitive setup code. 5. Execute generated Selenium test *. Takes the generated Selenium code, and the ptest fixture. Executes the test code, then allows it to fail and provide detailed output. 6. Main execution block *. Defines the website URL and scenario description. Calls the generate _Selenium _test function to generate the Selenium code. Prints the generated code. Executes the Selenium test using the execute _Selenium _test wrapper. Example generated Selenium code will vary. To run this example *. 1. Install Selenium * pip install Selenium. 2. Install ptest * pip install ptest. 3. Download a WebDriver * download the appropriate WebDriver for your browser, example Chrome driver for Chrome, and place it in your system's path. Alternatively, you can use a WebDriver manager like WebDriver Manager, install with pip install WebDriver Manager, to automatically download and manage the WebDriver. The provided code assumes Chrome driver is in your system's path. 4. Run the script * execute the Python script. It will * generate the Selenium code using OpenAI. Asterisk print the generated code. Asterisk execute the test using ptest. Important considerations for UI testing asterisk. Asterisk XPath selectors asterisk encourage the LLM to use robust and reliable selectors, example IDs, CSS classes, instead of fragile XPath selectors. If XPath is necessary, prompt for concise and specific XPath expressions. Asterisk explicit weights asterisk insist on the use of explicit weights, WebDriver weight, to handle dynamic content and avoid timing issues. Specify the maximum wait time. Asterisk error handling asterisk ensure that the generated code includes proper error handling, example try, except blocks, to gracefully handle exceptions that may occur during test execution. Asterisk page object model asterisk for larger projects, consider using the page object model, POM, design pattern. This pattern promotes code reusability and maintainability by encapsulating the UI elements and interactions for each page in a separate class. You can prompt the LLM to generate POM classes. 7. Conclusion. Generative AI offers a powerful set of tools for automating software testing. By carefully crafting prompts, integrating with existing frameworks, and maintaining human oversight, you can significantly improve the efficiency, effectiveness, and coverage of your testing efforts. Experiment with different techniques, track your results, and continuously refine your process to unlock the full potential of AI-powered testing. Remember that AI is a valuable assistant but not a replacement for experienced human testers. Good luck.